All right, welcome back. And today we are going to learn about lists. But before we learn that, let's talk about variables again. So I want to paint a picture of a variable. As you know, a variable stores a value. And in some ways, it's kind of like if a variable is a box. Like for example, I have a box here and with a name on it. So basically, I have a variable name and then it stores one value. So you can add a 6 on it. So now this variable contains a 6, or this box has a 6 in it. And the way to access this value is by calling the box's name, my variable. And then we have another variable with maybe another value, and then we can access this value by calling my other variable. The issue with this is that you can only put one thing inside this box. And the thing is, programs get complicated. Now imagine if I want to remember multiple things. For example, I want to remember my lottery numbers. So if I had to store them in a variable, it would mean that I would need 6 variables because there are 6 numbers in lottery numbers, I think. So I can't store, a 6 and then a 7 here. That's the limitation of a variable. But what if I have something like a list? Now, let's look at the code. Now, imagine I want to store my lottery numbers. Then what I would need to do is define number 1 is 2, num2 is 5, num3 is 14, num4 is 17, num5 is 20, and num6 is 35. Now, like I said, programs get complicated. What if it's not 6 numbers, but what if it's 1,000? Are you going to define 1,000 variables? No, that's way too messy. So now we have something called a list. Lists are one very basic data structure. We programmers, we use lists as a container to store multiple pieces of information that relate to one another in some way. For example, lottery numbers, right? This is the example that we have. So let's look at the anatomy of a list right now. So this is a list. Okay, it would usually look like that whenever you define a list. And then here, we've seen this before. That is the variable name, okay? And then this whole thing is my list. This is a list of numbers. And then here is a open bracket, which is list starts. You're telling the computer that the list starts here, and then the list ends here with a close bracket. That is the syntax. And then this is a element of the list. And then each of these commas, that's a delimiter. What a delimiter does is separate each value from itself. So for example, how many elements do I have here? Well, I know that this is not 13. It's one element of 1 and another element of value 3. So how many elements are there? 1, 2, 3, 4, 5, 6. There are 6 elements. So the size of lucky number is 6. Why don't we try to do that with the code now? So instead of all this hectic variable naming, let's just have nums. These are my lottery numbers, and this time, let's just define them 2, 5, 14, 17, 20, and 35. Let's run this. What would happen if I output nums? I get the whole list. Great. That's awesome. So I got the whole list, 2, 5, 14, 17, 20, 35. And then I'm curious, what is the type of nums? It's a list. Okay, great. That's exactly what I want. Now, this is all fun and games, but how do you actually access the information inside a list? Well, there's actually a syntax for that. It's open bracket. You insert an index like 3, and then you close bracket. So that actually means that I want to access the element with index 3 inside of my variable nums, which is a list. And then it would give us 17. Well, that's kind of weird. 17 is the 4th number, but, I get 17 when I put 3. So what happens if I put 0? I get 2, the first number. So this is a very common thing in programming, is that we start counting at 0. So we get 0, 1, 2, 3. All right. Now let's look at it more closely. So as you can see here, we have a list. So we can think of a list as a long box that can contain multiple elements, and you can have as many elements as you like, right? So the first box has 2 in it, the second box has 5. So this is basically a list, a container of multiple numbers. Using the information from before, what will we get if we access the index 2 of nums? Well, let's see, 0, 1, 2. So we would get 6. However, what about -3? How does that work? Well, before we go to this answer, I want to show you how we can think of indices in a more intuitive way. So I don't want you to remember that, oh, this is 0, this is 1, this is 2, this is 3, this is 4, like this is the 0th element, this is the first element. It doesn't really make much sense that way because, why does it start at 0? A better way to think about this is that these indices are not in the container. We are talking about the line in between. So for example, this would be 0, this would be 1, this would be 2, this would be 3, this would be 4, this will be 5, and this would be 6. So think of a ruler. When you have a ruler, this is not 1 centimeter. You start at 0. And then here, it's 1 centimeter. That makes a lot more sense, right? So how we use indices is, imagine if we have 2. So let's think of the index 2 of these separators. So we have 0, 1, 2, and then what's in front of 2? It's 6. That's why we get 6. So this actually works using negative numbers too. So here we would get 0, and then -1, -2, -3, -4, -5, and then -6. So what would 0 get us? Well, we know 0 gets us 2. So think of this array or this list as looping around, right? Which is the same way as if we went to -1 here, and then it would have been the element would have been 15 behind the 2. So basically it loops back around. So now that we have this information, what is -3? Well, like we said, 0 or -0, when you think about it, is 2. So that means whatever is in front of this line should be the answer. And because it loops around, it's number 2. So what's -3? -1, -2, -3. What's in front of 3? It's 7. So the answer is 7. Here's when this is actually super useful. So what does nums 1:4 give us? Well, this is actually a new syntax. This actually gives us a range. It gives us a subset of a list. So 1, what is 1? We have 1 over here. This is 1. So, okay, so we have this. And then 4, we have this guy. So it's right here. So what does that mean? So this actually gives us another list. It gives us the list from index 1 to index 4. And what is between 1 and 4? It's these guys. So this actually gives us 5, 6, 7. Pretty neat, right? So that is where the index, visualizing the index this way, that's where it becomes super handy. Let's do the same thing but using code. So we have our numbers already. So let's look at it again. So imagine if we want the element number 4 or the index 4. So we have 0, 1, 2, 3, 4. Look at where my cursor is. I'm not on the number. I'm on the lines in between the numbers, right? So now I'm at 4. What's in front of 4? It's 20. So it should give me 20. Okay, what about negative, let's say 2, right? So at the end, we have 0, and then -1, -2. What's in front of -2? It's 20. This gives us 20. Awesome. Let's do -5. So 0, 1, 2, 3, 4, 5. What's at -5? It's 5. All right, let's try ranges now. 1 to 4. So 0, 1, okay. And then we have 2, 3, 4. So we have 1 here and 4 here. So that means we're gonna get the list 5, 14, 17. Exactly, that's exactly what we got. Great, so that's pretty much how you access a list. But how do you modify a list? How do you add an item to a list? Well, I can actually easily teach you how to do that, but in our course, or at least the way I want to learn, is I want to teach you how to teach yourself. And the thing about programming is that you don't need to memorize everything. You don't need to memorize the syntax. You don't need to memorize all these commands. Like for example, when we learn type, what that does is it gives you a list. You don't need to memorize these commands. You just have to know that they exist. And the thing about learning programming is that the more knowledge you have, the more knowledge in terms of computer science or in general programming, the more you understand these concepts, the more you know what to search for on the internet. So, for example, I taught you that it's possible to add an item to a list. Like nums, what if I want to add another item after 35? How would I do that? Well, what you would do is you would search add item to list Python 3. I chose Python 3 because that's the Python version we're working with. And then what you would do, most websites are good enough, but I always search for the official documentation. So from Python itself, that's the official website for Python. I guess Google is really good too, but I'm gonna click Python. So here's what we call documentation. And forever in your programming career, you will read a lot of documentation because you're not supposed to know everything. You're not supposed to know how to do everything without looking for references. It's kind of like memorizing dates of all historical moments, or you can just search for them. So this is what we want you to do, is I want you to be able to search for these things yourself, because there are all these commands. I don't know all of these commands. I don't know 10% of it, but I know the existence of it and I know how to search for it. So for example, back to before, we want to add an element. So here we have different functions that you could do on your list. So here it says, add an element to the end of the list. Oh, great. That's exactly what we want. So how do we use that? It says list.append and then x. And I'm guessing that x is the value that you want to append and list is the list. All right. So let's try that. So nums is the list. And then we go back. It says the word append. Okay. Append. And then open parentheses. And then you can add a value like 4. And then you press enter. Okay. I'm not sure what that does, but now if I look at nums, I have a 4 after my 35. So I've successfully appended a value to my list. That's awesome. But what if I want to insert in between two values, right? I want to insert it like here after the 2. I want to insert a 4 between 2 and 5. How would I do that? Okay, let's continue reading the documentation. This extends the list. Okay, doesn't seem like that's what we want. Insert an item at a given position. Okay, that's exactly what we want. Okay, but how do I use it? The first argument is the index of the element before which to insert. Okay, so we have I here. So as you can see, it takes 2 parameters. Remember functions? This is a function that acts on this list. So a.insert 0x inserts at the front of the list. Okay, let me try that. So nums insert 0, it would be at the front of the list. What do we want to insert? Let's insert 5. Okay, what happens now? Now we have a 5 in the front of the list. Okay, cool. Remember what I said? I wanted to add an element between 2 and 5. So what is this index? Okay, 0, 1, 2. Okay, so it must be 2. So I want to insert something at index 2, and I want to insert the value 4. Okay, let's look at nums. Aha, now I have the 4 in between the 2 and the 5. Excellent, that's exactly what I want. All right. Okay, so now you might ask, okay, what about removing an element? I want to remove an item from a list. How do I do that? Well, let's check it out. Go back to your documentation, keep reading, and then, oh, that seems promising. It's the word remove. Remove the first item from the list whose value is equivalent to X. Oh wait, that's a little bit different. But what about pop? This is also remove. Remove the item at the given position in the list and return it. Huh. Okay, I get it. So the difference is that here, it searches for the value and then it removes it. But pop, you give it an index, as you can see, I, and then it's gonna remove it from the list. All right, let's try it out. So what if I want to remove 14? what is this gonna do? So I have the element 14, I wanna remove it, okay? What does my list look like now? Haha, it is removed, that's great. Okay, what if I call it again? What would happen? Ooh, there's an error. It says X not in list. So it's saying that 14 is not in the list, so that operation did not work. Okay, interesting. So that's how you remove an element if you know its value. But what if I just want to remove, say, the first element? Then it's called pop. Then the first element, the index is 0. If I pop it, oh, I get 5. Interesting. So that means, why do I get 5? Well, if you read the documentation, it says it removes it and then it returns it. Okay, that's great. Okay, but I don't really need that now. I just want to see what my list is. And as you can see, I have removed the 5, which was the first element. Okay, let's pop again. All right, I removed 2 now. Okay, my list is a lot smaller now. Wait, what would happen if I don't give it a value? Because when I go here, there's a bracket sign. So usually when we see something like this, like a bracket, it means it's an optional parameter. As you can see, this is a function, and then you have a parameter, and then because it's in brackets, it's optional. Okay, what if I don't add anything? I get 4. Huh. Well, 4 can be the last element or the first element. So I'm not sure which one it is. But let's look at our array. Oh, it seems like we have removed the last one because the 4 in the start of the array is still here. So I guess pop means removing the last element. Okay, interesting. All right, let's remove 17. How would we do that? Well, what is the index? 0, 1, 2. What's in front of 2? It's 17. So let's pop the second index. All right, we got 17. Looks like it works. And there you go. We have this array and we have popped 17 out of it. Now let's go back to our documentation. Let's read. So remember, I actually read this one, insert an item at a given position. And it says insert 0x, inserts at the front of the list. Okay, and insert length A is equivalent to append. And remember what append is? Append is when you add an element to the end of the array. And then it says this is equivalent. What the hell is len A? What is len A? I've seen this multiple times. What is that? Well, why not we try it out? So A is the list, so why don't we try len A? Let me run this so we can get a fresh run again. What will nums be? Is it the 3 elements or is it the 6 numbers? It's the 6 numbers because when you click run, you restart it. Anyways, so what is len nums? What is that? It gives us 6. 1, 2, 3, 4, 5, 6. Huh, can it be? Okay, let me pop a number. Okay, pop the number. Leng nums. Huh. So I think leng means the length of my list or the number of elements inside my list because we have 1, 2, 3, 4, 5 elements in my list and then it will output 5. Great. So how were you able to know? Well, we could try it, but we can also read documentation. All right, this is super important. Forever in your career, you will be reading a lot of documentation to understand how functions work. There are libraries that other people write or other functions that other people write, and the only way to know how to use them is by reading documentation. You can't always just look at the code because that takes a while. So let's learn how to search for documentation. What if I do lang python 3? What is that? So here, okay, it's in built-in function. So let's search for len. Oh, as you can see, Python interpreter has a number of functions and types of built into that are always available. They are listed here in alphabetical order. So this is the one we want, leng. If we click it, it says return length number of items of an object. So in our case, the object is a list. So there we go. We know what leng does now. We put leng and then it gives us that. As you can see, it works for strings, bytes, tuple, list. We did it on a list. Oh, apparently it works on string too. Wait, let's try it out. Okay, let's say hello. All right, how many letters are in hello? 5. Oh, wow, okay, so that's what it does. Let's do hi. Oh, nice. So now we learned a new function. Now the thing is, you don't need to memorize these functions. There are so many functions here that I didn't know exist, like oct. What is oct? But if I click it, I know that, oh, it converts an integer number into octo string. Okay, got it. As long as you understand the concepts and theories in computer science, you know that things can exist and cannot exist, then you know how to search for these things. So that's the thing about programming, is it's not about learning the language by heart. It's not about learning the syntax or all these built-in functions by heart. I don't know, like there are so many functions here that I didn't know existed, but it doesn't matter, because whenever I want to search for something, for example, I want to do, let's say I want to know how to make a dictionary. Then maybe here they says, oh, it creates a dictionary. Great. I can just search for it. The key is to understand what is possible in programming and then be able to search for it and learn how to do it in that language. That is the key of programming, is to understand the fundamentals, which is why I called it Fundamentals of Programming Using Python. This is not a Python course. It's like, yes, I'm teaching you Python, but most importantly, I'm teaching you the fundamentals of programming. And then Python is just a tool for us to use, for us to understand the programming fundamentals. For example, imagine if you're working on C++. You could write C++ length of list. Now we know how to get the length. It's not len, it's size. See, I just read the documentation, I see an example. So imagine if I have a list of ints, okay, great. And then I just do dot size and I'm gonna get the size of my array. I didn't know how to get the length of a list in C++, but all I have to do is search for it and then I'll get it. And then with that understanding and knowledge, you can learn any languages. All right, and that's it for this lesson. On the next one, we are still doing lists, but we're putting all these things together and we are going to see how powerful it can get. We're going to build functions that are a lot more useful now, because now we know how to use lists. And then after that, we're going to go back to loops, and then we're going to see how loops and lists can work together to make really powerful functions. See you later.